So in this video, we're just going to look at some examples of figuring out where we're concave up, concave down, and all of that stuff. And to get us started, please copy down that problem. I want to figure out the concavity and points of inflection for that function over there. F of x equals x to the fourth minus 4x cubed. The video will pause, copy that down. Our work is going to look very similar to the work that we did with our increasing, decreasing relative extrema, except instead of analyzing the first derivative, we need to analyze the second derivative. First thing I'd like you to do is take a moment and calculate your f double prime of x. F prime of x, the derivative, is 4x cubed minus 12x squared. Do it again. F double prime of x, wait a minute, that's not right. How about 4x cubed, sorry about that, 4x cubed minus 12x squared. F double prime of x is 12x squared minus 24x, that's more what I was expecting. And I have my second derivative. I then need to set this second derivative equal to 0 or figure out where it's undefined. I'm going to say 12x times x minus 2 equals 0. X equals 0 and x equals 2. Technically, these are not critical values. Critical values occur where the first derivative equals 0 or is undefined. This is the second derivative. I'm going to call these things possible points of inflection. Possible, I'm just going to abbreviate, POIs. Possible points of inflection. I could have points of inflection at x equals 0 and x equals 2. My concavity could change over there. I'm going to make a number line and I'm going to label it f double prime. Again, the labeling is important because eventually we're going to have multiple number lines at one time and we need to know what we're talking about here. So this is f double prime. I need to test my regions. Well, if you plug in 3 to your second derivative, and I want to plug into the factored version of my second derivative, plugging in 3 gives me a positive times a positive. It's positive there. I'm not going to put my little positive slope symbol above it. Instead, I'm going to put my concave up symbol above it. When you plug in something between 0 and 2 to your second derivative, what do you get, positive or negative? Plugging in 1 gives me positive, times a negative gives me a negative, so I'm going to be concave down over there. What about if you plug in negative 1? Is the second derivative positive or negative? Negative times a negative will make that a positive. So as far as the analysis goes, I am concave up from negative infinity to 0, and then between 2 and infinity, because f double prime is positive there. Go fill in your concave down. I'm concave down between 0 and 2, because f double prime is negative there. 0 and 2 are possible points of inflection, but I'm saying that they're actually points of inflection because concavity is changing at those x values. So I'm going to say I have a point of inflection at 0, comma, I'll get my other coordinate in a moment, and 2, comma, I'll get that in a moment. Why? Because f double prime changes signs there. How am I going to get the y-coordinates? Like always, y-coordinates come from the original. This is going to be f of 0, 0 to the fourth minus 4 times 0 cubed, oh, that's 0. This one's going to be f of 2, 2 to the fourth, minus 4 times 2 cubed. That is, let's see, 16 minus 32. I think we're going to get negative 16 over there. And we've got our concavity. Will look like an upright parabola in the first region, upside down parabola between 0 and 2, upright parabola between 2 and 3. Next one. F of x equals x plus 1 over x minus 3. Please go find the first derivative and then stop. I'm going to go use the quotient rule to do this. So f prime of x is going to equal low x minus 3 d high is times 1 minus high x plus 1 d low is times 1. Draw the line and square below over x minus 3 squared. X minus 3 minus x minus 1 over x minus 3 squared. I'm going to get negative 4 over x minus 3 squared. To find the second derivative, it's actually going to be a lot easier if I write the first derivative not like that, but instead like negative 4 times x minus 3 to the negative 2. Because then I can just use chain rule and not have to bother with like quotient rule or anything like that. So go take a moment, find your second derivative. F double prime of x is going to equal 8 times x minus 3 to the negative 3. And I'm going to say this is 8 over x minus 3 cubed. Where do we have a possible point of inflection? Set the denominator equal to 0. I've got a possible POI, point of inflection, at x equals 3. So I'll do my number line. And we're going to plug into our second derivative. What happens when you plug in something in this region? Plug in 4. 4 minus 3 is 1. Cubed is 1. 8 over that, positive number there. Concave up here. What happens when you plug in something over here? What sign do you get? Plug in 2. 2 minus 3 is negative 1. Cubed is a negative. 8 over that makes that negative. So go finish this off. Write down where you're concave up and where you're concave down. Concave up between 3 and infinity because f double prime is positive. Concave down from negative infinity to 3 because f double prime is negative. And then point of inflection at 3 comma, take a moment, plug in. What do we get for the y-coordinate? Let's see, remember we're plugging into the original function, so f of 3 equals 3 plus 1 over 3 oh, hold on, wait a minute. I'm getting 4 over 0 here. There's an asymptote there. There's a vertical asymptote at x equals 3, which means I don't have a point of inflection, can't possibly have a point of inflection where my function is undefined. I'm changing concavity there, but it's not a point of inflection because there is no point. So I guess I can just say no POIs. I have one last example. Let's take a look at this. F of x equals x minus 2 cubed times x minus 1. To find f prime of x, you need to use the product rule, but within there, you need to use the chain rule when you go to do the derivative of the first part. Get your first derivative, and then see how far you can go with factoring your first derivative, like we did 2 units ago, back in section 2.4. I'm going to get f prime of x equals first x minus 2 cubed times derivative of the second is times 1, minus second x minus 1 times derivative of the first is 3 times x minus 2 squared times 1. F prime of x is equaling x minus 2 cubed minus 3 times x minus 1 times x minus 2 squared. My GCF that I can take out is an x minus 2 squared, so I'm going to go do that. Over here I'm left with an x minus 2. Over here I'm left with a minus 3 times x minus 1. Keep going. That's x minus 2 minus 3x plus 3. I think my first derivative is going to be x minus 2 squared times, wait, hold on. I did something wrong. Oh, wow. This should not be a minus. Sorry, I don't know what I was thinking. First times derivative of the second plus second times derivative of the first. Wow. We're going to get something like that, which will give us 4x minus 5. Sorry about that. Hopefully you got that answer, not whatever I was trying to create. I need the second derivative, which means you've got to go do this again. Product rule and chain rule within it. See if you can calculate your second derivative. First, x minus 2 squared times derivative of the second is times 4, plus second, 4x minus 5 times derivative of the first is 2 times x minus 2 to the first times 1. F double prime of x is 4 times x minus 2 squared plus 2 times 4x minus 5 times x minus 2. Looks like my GCF here at 4 and 2, I can take out a 2. X minus 2 squared, x minus 2. X minus 2 can come out. So I'm going to get 2 times x minus 2. Got a 2 left from the first piece times x minus 2. And a 4x minus 5 left from that second piece. Keep going, and when you're done, tell me where the possible points of inflection are. Let's see, you know, I guess I could leave this, but I also could factor out a GCF from here just to make it a little bit cleaner and easier to plug into. Could take out a 3 from those. So f double prime of x equals 2 times x minus 2 times 3 times 2x minus 3, or really 6 times x minus 2 times 2x minus 3 for that second derivative. And hopefully you said there are possible points of inflection at x equals 2 and x equals 3 halves from those two parts. See if you can finish this. Go do your analysis, do your plugging in, and let's finish this one up. Plug in 3. Positive, 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 it's positive. Plug in something between 3 halves and 2, like 1.75. Positive, negative, positive. So that's going to be negative. Plug in 0. Positive, negative, negative, that's positive. And concave up between negative infinity and 3 halves. And then again between 2 and infinity, because f double prime is positive. And concave down between 3 halves and 2, because f double prime is negative. And there are points of inflection at 3 halves, comma something, and 2, comma something, because f double prime changes sign. There. And to find these, remember we're going to plug back into the original. So f of 3 halves equals, oh goodness, let's see, 3 halves minus 2 cubed times 3 halves minus 1. This is 1 half cubed times, oh wait a minute, no it's not, sorry about that. 3 halves minus 4 halves is negative 1 half cubed. 3 halves minus 2 halves gives us 1 half over there. This is negative an eighth times 1/2, I think negative 1/16. 2 comma, this is going to, oh, this is going to be way nicer. We're just going to get 0 out of that.